Good morning, children. Today we are going to learn on scientific notation. You might have come across big numbers and small numbers in your daily life. You might have seen so many examples of bigger number and smaller number. So I have given you two examples here. One big number and another smaller number. 234 million and another small decimal number is given. When at a glance, when you are asked to read the numbers, so it is difficult for you to read the number, right? So what scientific notation will do is, scientific notation help us to write bigger number and smaller number in easy form. We just need decimal idea and powers of point to write the numbers in short form. And the scientific notation will reduce the very big number to less than 10, keeping the track how many tens to multiply to get that original number. Or there is rule, the whole number should be less than 10 but greater than 1. So this is the rule for the scientific notation. Okay, so when we further do practical work, you will understand. You just have to keep in mind that scientific notation help us to write the bigger or smaller number in easy form. You just have to keep this in mind. Okay, this is the importance of scientific. Now let me show how to write numbers in scientific notation. So this number, okay, 123 million, that's a big number. So how to write in scientific notation? Let me show you. You know that in any whole number, for example, let's say 24, I say 24. So this whole number, you should know that there is decimal point after 4. Okay, it is same as 24.0. We don't write 24.0 because after decimal point, if you have 0, it is same like the 24 only. So that's why we don't usually write this decimal point after whole number, but you should know there is a decimal point. Okay, so 123 million. So how to write in scientific notation? Scientific notation, we just have to reduce this bigger number by tens, each time by 10. So here I'm reducing by 10. Okay, if I multiply by 10, I have reduced by 10 here. Okay, this number is reduced by 10 and I have multiplied 110 here. So if you multiply this, you get the same number as first one. So again further we reduce. Okay, now I have already reduced by 110. Now I have reduced by 2 tens. See? Okay, here we have how many zeros? 5 zeros. Now it became 4 zeros. So this is how we reduce, but we are at the same time we are multiplying next in the another hand, right? So when we multiply, we get the first number. The number should not be changed. Okay, it's just like saying the same thing in another way. So it is the same number as first one. We are just writing in another form. Now again, when we reduce this first two number, so here our power is increasing, right? Here we have 1/10. Now this one is same as 10 to the power 2, right? Now since we have reduced another 10, now the power has increased. So likewise, when you keep reducing first hand, the power keeps on increasing. 5 now. See, now it becomes 6. Now the rule says, is in the scientific notation rule says the whole number should be less than 10 but greater than 1 or equal to 1. So I am further decreasing. So now this decimal point, I told you there is decimal point of whole number, so this decimal point has come this side, so it is the power has increased. Now decimal point has moved this side, the power has increased. So our final answer is 1.23 times 10 to the power 8. So this is our scientific notation for the first number. When you multiply, you get the same number as the first one. It is just another form of writing. Okay, so this is our scientific form. Now another thing is, here when your decimal point is moving right, it is moving left hand side, right? It is moving left hand side. So when your decimal point is moving left hand side, so your power is going to be positive. So keep this in. Okay, next one is the smaller number, 0.00000023, isn't it? So see, when we have this type of number, it becomes monotonous for us, isn't reading 000. See, so when we have scientific notation, it is easy for us to read. So how to change this smallest number into scientific notation? So our decimal point is here and it's going to move right hand side. 0 we have 6 zeros here and 2 3. Now my decimal point is moving this way, 0 point. So how many? 1 2 3 4 5. Then now I multiply. So when your decimal point is moving right hand side, your power is going to be negative form. Okay, negative. Now again I'm moving this side, so 0.000003, and my power here is -2 because I have reduced. Now further it is moving this way, 2 3. My power has become -3. Now moving this, my power -4. Okay, so likewise it moves on. -5. Move here, 0.23 times 10 to the power 6. I told you the rule says the number should be less than 10 but greater than 1 or equal to 1. So I cannot keep 0.23, so it should not be 0. My whole number should not be 0. So 2.3, and my power has become 7. Sorry, this is old form of writing 7. So this is 2.3 times 10 to the power -7. So this is the scientific form for the smaller number. So when you multiply this one, you are going to get the same thing. Okay, so what you have understood, when your decimal point is moving right hand side, your power is going to be in negative form. And in first place, when your decimal point is moving right hand side, when your decimal point move right hand side, your power is going to be positive form. And when your decimal point is moving right hand side, your power is going to be negative form. First one is right hand side, isn't it? Right hand side, and this one is moving left hand side. Okay, let me stress again. Bigger number. Okay, when we have bigger number, our power is going to be positive. When we have smaller number and when we are changing into scientific form, our power is going to be negative. Okay, or I can give some example here. If you were here, you would have given me example. Since you're not here, I'm going to write my own example. Okay, this is a bigger number, so when I'm changing into scientific form, my power is positive because my decimal point is going to move right hand side. And when I have smaller number, my decimal point is moving right hand side, isn't it? So my power is going to be negative form. When my decimal point moves right hand side, it's positive. So I'm telling you again. Okay, keep this in mind. Okay, another interesting thing about the scientific notation is it helps us to compare numbers easily. Look at these numbers. Oh my god, isn't it so many zeros? So at once, if you are asked to compare, you will need time to think about the place values. So scientific notation will help us to compare the numbers. Let us see how. So the first one, let us change this number into scientific form. Let us use the rule. The whole number should be less than or equal to 1 but less than 10. So our decimal point is going to be right after 1. 0.232, then times 10. How many powers after decimal point? How many powers or how many digits we have? You just have to count, isn't it? After decimal point, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17. So when it is bigger number, our power is positive form. So the second one, let us use the rule. The number should be greater than or equal to 1 but less than 10. So it is 3.42 times 10 to the power how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Whoa. So our power is same, right? So when we have powers of 10 same, power of 10 same, we just need to compare the whole number. So definitely, isn't it, the whole number 3 is greater than 1. So that means this second number is greater. Okay, so second one, it is smallest number, so our decimal point is moving right hand side. So that means our power is going to be negative form. Here our decimal point has moved left hand side. That's why our power is 17. Now our power is going to be negative form. Now let us use the rule less than or equal to less than 10 but equal to or greater than 1. So decimal point is 5.4 times 10 to the power how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So negative 13. So likewise 3.22 times 10 to the power negative how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, right? Again 13, really? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12, okay. 12 because our decimal point is right after 3. So here our powers are different. When powers are different, we don't have to look at the whole number. We compare the powers, negative 13 and negative 12, isn't it? In negative integer, you might have learned in negative integer the smaller number becomes the greater value, right? So negative 13 is less than negative 12. That means this number, second number, is greater than the first one. So this is how we compare using the scientific. Okay, now we are almost to an end. How to write scientific notation into regular form. So you know how to write standard form into scientific notation. Now you also have to know how to write scientific notation into regular form. That means you have to know both ways. Okay, let me give you an example. Let's say 3.76 times 10 to the power let me give 4. So when you have positive form, it means it is going to be a greater number, right? So this is very simple. Again, you don't have to do anything. You just write the number. Okay, right after decimal point, count 4 digit. Look at the power, count 4 digit. So 1, 2 is already here, isn't it? So 3, 4. See, so your number is 37,600. Okay, so let me show another example having negative exponent. So let's see this. So this one, when you have negative exponent, your number is going to be smaller, right? So that means you have to move decimal point 3 places back. So that means one place is already here. Okay, that means 3. So 1, 2, 3, right? So we are moving 1, 2, 3. See, after decimal point 1, I can show you here 1, 2, 3. Here your decimal point is moved 3 times back. 1, 2, 3, right? That means your number is 0.0013. So this is how you write scientific notation into regular form. If you want to see it back into scientific notation, so this is your standard form, and if you want to write it in scientific form, you use the rule. The whole number should be equal to 1 or less than 1 equal to 1 or greater than 1 but less than 10. So 1.3 times 10 to the power, how many times you have to move? To 1, 2, 3, right? So moving this side, right? Negative. So see, this is how you get, okay? Getting back and getting to the regular point. So this is how you write. Okay, thank you. So this is all for today, and you will be getting some homework from your textbook. If you don't understand, go through the videos again, okay? And stay home, stay safe. Don't consider lockdown as your holiday. It is an opportunity for you to learn with a teacher comfortably at home. So study hard, okay? Stay safe.